invocation on the right-hand side to take care of. So that means I have to invoke S5 again on line 9, but this time of row 36 of the trace. Whenever I invoke S5, I have to allocate 3 columns. Which 3 columns should I allocate? Yep, because they were just deallocated, which means I can reallocate it at this point. So once again, we have return info and also x. X is an alias of column C. N is 0 again, because the N on the left-hand side refers to column H. Column H has a value of 1. 1 minus 1 is 0. The return info is going to be like this one, because this is what I'm trying to execute, except the invocation itself is replaced by a single question mark. So it becomes 9 return 10 times question mark. Oops. Like that. Are we doing okay with this? Okay. And then once we set up the 3 columns, we can go back and restart execution from the beginning of the subroutine, which is line 4. N equals to 0 is true, because N does equal to 0. Then we go on to line 5. Line 5 is adding 1 to column C. Column C has a value of 10 right now. 10 plus 1 is 11, and 11 is now the value of column C. Then we go to line 6. We are going to execute the return statement, returning the value of x. X refers to column C. Column C has a value of 11, so we are effectively returning a value of 11. When you execute a return statement, you find the return info cell, you copy, you paste, you change the question mark to the value that you're returning, and you're done. Do not simplify it to 110 at this point, because this is not the right time to do it. After line 6, we go to line 11, which is the end of the subroutine. We deallocate the columns that we allocated earlier, and then we go back to line 9. This time, when we go back to line 9, are we ready to actually perform the return statement? Yes, because I can figure out 10 times 11 is 110. When I execute return 110, what I need to do is to find out what is the rightmost return info cell, and that turns out to be G27 at this time. In other words, this is my verb, this is my action to perform, this is what I'm acting on, this is my object, and this is my result. The result is the object, but with the question mark resolved to a particular value. Okay, so basically it's the same mechanism being used again. And I'm done with line 9. Okay, I do not simplify 42 times 110 at this point. I move on to line 11. Line 11 is the end of a subroutine. I deallocate those 3 columns. Okay, and then I go back to line 9, because this is what the return info cell is telling me, is to go back to line 9. In fact, line 9 now looks like this. Am I ready to return? Okay, if I'm ready to return, I have to locate the rightmost return info cell. Column G is already gone, so I know I cannot use column G. So the only return info cell left is column D. So this is my verb, this is my object. The result of the action is replacing the question mark with the return value, which is 42 times 110, and that's 4620. Okay? Are we doing okay? Because we are almost done with this. Almost. Okay? And then we go to line 11. I'm done with line 9, which is the return statement. I go to line 11. I deallocate, all these columns. And then I say, where do I go? Well, go back to line 13. Do I know what value I'm supposed to print now? Okay, so we go ahead and print that value either to the screen or on a piece of paper. Then we move on to post, because there are no additional lines after line 13. Well, the essence of the trace does not take an hour. It takes half of that time. The other half is just repeating the same exercise just to make sure that we got the concept down. Okay.
Were you able to blow it up so we can at least just see how the whole trace?
The shape, sure. absolutely.
Well, you're going to save this file, right? So
Yep. Mm-hmm. Yep. Thanks to my new flash drive, we don't have any file corruption issues now. If you just look at the shape of the whole thing, it is very, very symmetric in this case. It's a little bit long, but it is very symmetric. You can see how the columns are allocated all the way out, in, again, out, and then out again, and so on. Okay. You can also look at it at using a different view, because you can basically look at it from the perspective of a tree. This is the first invocation. The first invocation will basically perform a recursion, and it will split into two. Each one of those will split into two as well. Okay, and let's see, how many times do we actually have to execute it? I think this is the shape of the whole thing. When you are executing the algorithm, what you're doing is you're doing a traversal like this. You come down here and say, oh, I cannot return anything here until I know the result of these two. So you move down, and then you go to the last one. You finish this one here, it becomes a single return value. It goes back to this one, and then this guy says, okay, now I have the left-hand side resolved, but the right-hand side is not resolved yet. So it goes in and tries to resolve the right-hand side. And when the right-hand side is also resolved, it comes to the same point again. And this time you have both the right-hand side and the left-hand side done. As a result, this entire value is done, so it will return all the way back to this point. But at this point here, the right-hand side is unresolved, so it will try to go ahead and resolve the right-hand side. But to resolve the right-hand side itself also has a left-hand side to resolve, go back, it has its own right-hand side to resolve, go back. When you have the left-hand side and the right-hand side both resolved, then it becomes a single value. It goes all the way back here. Now this guy has both the left-hand side and the right-hand side resolved, and it becomes a single value. And this guy goes back to the print statement, and the print statement prints the actual value. So it's helpful to see it as, in this view, because now you see how the whole thing is structured. It is basically, quote unquote, a tree, because you're just, traversing these nodes in a particular order. Okay, are we ready to move on to the next question? Okay. I saved it already? Yes? Yes. Okay, very good. And it's still recording? Yep. Just double checking. Okay, next we'll tackle the second quote unquote most difficult problem. I don't think it really is that difficult, but we'll take a look at this one. Observe the following code. The post condition is of line 37 is x equals to 28. What can be deduced as the precondition of line 32? Explain your rationale leading to the suspicion of the precondition of line 32. Then use forward pre- and post-condition derivation to arrive to the conclusion that post 37 is in fact x equals to 28. Okay. All right, let's take a look at this one, and we'll talk about how to try to resize the screen. And there we go. Okay, because I need to look at this and work on it at the same time. Okay, let's go ahead and work on this one. If I run out of time, today, what I'll do is I will do a video recording to explain all the other answers. So this way, you cannot easily ask questions, but at least you know what is the answer to the other questions. Yep.
Is there going to be an extra credit assignment?
Yeah, I can do an extra credit assignment.
Did you make it really easy?
Yeah.
I was hoping that no one will remember to mention that. All right, let's go ahead and deal with this one. All right, so what we need to do is to kind of go backwards and say, well, knowing that the post condition of 37 is x equal to 28, what do we know about, let's say, line 35? In other words, we are executing the program backwards, but this time we have a conditional statement. Okay? Okay, so if you look at the picture, there are two ways to get back to line 35.
You know, yeah. Post 34 axis greater than 30.
Okay, one thing you can do is to draw a picture. A picture really, really helps in situations like this. Okay. This is a conditional statement where only one of the branches has something to do. It's kind of lopsided because only one side has an action to perform. The action to perform is x gets x minus 3. Okay. Now, obviously, this part I cannot capture using the screen capture because it's not looking at the whiteboard. And we know that at this point here, after the merge of these two branches, we know that x equals to 28. That's what we know. So now the question is, can I go back and say, something about this point here? Yep.
You try going back to both branches and see which one gives you a logical possibility.
Exactly. So one thing you can do is basically say, now this part, when you are reversing, you don't have to use the pre and post condition notation. You can just say that knowing that post 37 is x equal to 28, that means, pre 35, there are two possibilities. One possibility is we did not go through the x gets x minus 3. Okay? If we did not go through the x equals x minus 3, that means, x equal to 28 at that point. Or the alternative is that we actually got through x gets, x minus 3 in order to get there. So if we did go through line 36 to make x equal to 28, what would x be before that line? 31, right? Okay, so is that making any sense? Knowing that post 37 is that x equals to 28, we can come back and say, okay, before line 35, we know that x can either be 28, which means it did not go through line 36, or x equals to 31, in which case it has to go through line 36. Is that making any sense? Okay, because we have two paths to go back. Now, knowing pre-35 is like this, we can know post-42 is exactly the same thing because the two conditional statements are sequential. They are right next to each other. So now I can apply the same reason. Okay, I can apply the same reason and say, well, maybe we went through line 33, maybe we did not go through line 33. So this means, if I look at pre-32, I can say one of two things. We can basically say that x was 28, x is 28 by the time we get to line 35, and we did go through x gets x plus 1. So that means in that case, x has to be 27 to begin with, right? Or x, became 28, but we did not go through x get x plus 1. So that means x can be 27 to begin with, or x can be 28 to begin with. And the same rationale applies to the other side. We can say that x, we did not go through line 33, and that means x is 31 to begin with, or we actually went through line 33, that means x was 30 to begin with. So these are my alternatives. X can be one of these four possible values. But some of these are impossible. Okay? Some of these are impossible because if you look at the condition of line 32, there are some cases where we will not go through line 33. In other words, this one is not possible. Okay, so you can say x is 27 at line 32